the angles subtended by the arc or by the same chord or arc of a circle in the same segment of the circle are equal. Or simply put, I used to call it angles in the same segments of the circle are what? Are equal. That means angles that comes out from the same segment, that are in the same segment of a circle, or that comes out from the same chord or arc of a circle are what? Are equal. This is the third theorem of the circle theorem. And in this theorem, we are going to analyze that theorem. We are going to prove this theorem. And then we are going to take one simple example on how this theorem can be solved. Hello everyone. Welcome to our video tutorial for today. In today's tutorial, we are going to analyze theorem 3 that says angles in the same segment of a circle are equal. Now we're going to analyze this theorem and we're going to find out how to solve this theorem using a simple example. Don't forget to give this video a like and also subscribe to this channel so that you can get our subsequent video content once they are published. Now let's go straight to this theorem. Now in this theorem proves that angles that comes out from a chord, no matter how many angles they are all equal. If you want to define it very well, you can say all the angles subtended by the same chord of a circle in the same segment of the circle are equal. So that means all the angles must come from one chord and they must be in the same segment of a circle. Now remember that the segment of a circle, we can have the minor segment and the major segment. So if we have an arc A and B and we have angles that emanate from this arc, no matter how the angles are, this comes here and goes this way, this comes here and goes this way, this comes here and comes this way, and this comes here and comes this way. It says all these angles are what? Are equal. Why? Because they come from the same chord and they are in the same what? Major segment of a circle. That's exactly what that theorem wants us to know. So all angles in the same segment of a circle are what? Are equal. So no matter how the circle is, you can draw it from here. It comes this way. If it comes like this, if it comes this way, no matter how it comes, they are all equal, so long as it emanates from the same chord and is in the same segment of a circle. Now, how do we prove this? I want us to prove this so that we can also find it a bit easier dealing with questions like this. Now, let's see how we can prove this analysis. Now we are going to do some construction. If we have a circle, and in that circle we have a center point to that circle. If we have a center point to that circle, we want to do some construction. Let's assume that this is the chord AB, and this chord will construct a line to this point. This is the center O. Now, if we say this angle, let's construct this angle comes this point and it goes this way. That's the first angle, and then we'll have an angle that comes this way and also comes this way. This is the second angle. So let's take this as P and let's take this as Q. This is the construction we are going to do. Remember, this is the center of the circle and this is the chord. So we are giving circle, the circle APQP. That's the circle we are given, and in this circle we are asked to prove that this angle, which we will call x1, is equal to what? X what? Is equal to x2. That is what we are asked to prove. Now, if we have done this construction, we have constructed this. Now let's look at how we can analyze this. Remember that since this is look at this point, this construction we've done, this is more like this angle sustains what? This angle. So angle AOB, this is the angle at the center. This is the angle of the center of this, right? So this is the angle at the center. So angle at the center, remember at theorem 2, angle at the center is equal to 2 times angle at the circumference. So we can now say that our angle AOB is equal to 2 times the angle at the circumference, 2 times x what? Angle x1. The same thing goes here. If you trace this down, you find out that this angle is also the angle at the center of this angle at the circumference. So we can see that angle AOB2 is still equal to 2 times what? X what? X2. So that tells us something, that angle AOB is the same for the two what? For the two values. So that means angle AOB is equal to 2x1 and angle here is equal to 2x1. Now for the two angles, we can find out that angle AOB is still equal to angle what? AOB for the two angles. So if 2x1 is equal to 2x2, what do we have? 2 clear 2. We'll come to see that our x1 is equal to x what? 2. So this proves the law, that proves the theorem that angle here is still the same angle here. So angles in the same segment of a circle are absolutely what? Equal. That is exactly what it tells us. Now, for this reason, you come to know this reason, that angle at the center is equal to 2 times angle at the circumference. Of course, that's what we dealt with in theorem 2. So if we prove that and we find out that they are the same thing for these two angles we've constructed, this for this and this for this, we'll find out that they are the same thing. That means their angles will be what? Will be equal. So you see now, it is a proven fact that angles in the same segment of the circle are what? Equal. Now let's consider one simple example to clarify this, and then see how we can get a solution to that sample. So on this third theorem, the question says, in the diagram below, 0 is the center of the circle. BOC, this line on it shows that it's a line, it's a diameter, and angle ADC is 37 degrees. Find angle ABC. Now, if you are given this question, I want you to note something. Remember the third theorem of the circle geometry. It says angles in the same segment of a circle are what? Are equal. So for this circle, for this theorem to stand, the angles must emanate from the same chord and they must be in the same segment. Now I want you to analyze something. You are going to see something. This already they told you is a what? Is a diameter. So that shows you that this diameter divides this angle into two equal parts. But then CA, which is part of what we are looking for, CA is a chord. We are looking for this angle. And remember that this angle emanates from this chord. And this angle also emanated from this chord. So this angle is the same thing as this angle because they are all from the same chord and they are in the major segment of this circle. Why this is the minor what segment? Remember, angles in the same segment of a circle are what are equal. Now the angles must come from the same segment and they must emanate from the same what? From the same chord. So if this is the case, we can now say that angle CDA is equal to angle CBA, or just as they put it, it can be ABC. So that means if angle CDA is 37 degrees, therefore angle BABC is equal to 37 what degree. What's the reason? Angles in the same segment of a circle. So remember, when solving questions on circle geometry, any step you take, you must state the reasons why such steps we are taking. That authentifies your solution. So, and that tells your examiner that you truly know what you are doing, that you truly know the theorem that are all found in the circuit theorem. Now, this is exactly the question, and you see, question that comes from this second theorem are very, very easy questions, although they have to do with questions that combines all other theorems. But when you see questions like these, you can easily work with them and then find solutions to them. As time goes on, we are going to solve complex questions that has to do with application of many theorems. You are going to see how that will be resolved. Now, this is exactly what I have for you for today. I know you do love this video. Do share this video with your friends, and don't forget to like and subscribe to our channel for more of our videos. Thanks so much for watching.